Hello again. This is the notes, second part of the notes for section 7.1 for advanced geometry, talking about Pythagorean theorem. The first part of this video is a new term, Pythagorean triple. Okay, so what that is, you don't have to copy all of this down, but you got to copy down some of the main ideas and a couple of examples of it. Pythagorean triple, set of three positive integers, meaning no decimals, a, b, and c, that satisfy the Pythagorean theorem. The most basic and most common one is the 3, 4, 5. All right, you plug in these numbers into Pythagorean theorem and it'll work, meaning it will become equal. Now, in a right triangle, the hypotenuse will always be the longest side. So, just as an example, let me get a color that shows up a little bit better. 3 squared plus 4 squared should equal 5 squared. Working my way up. Whoops. 3 squared is not 16. 4 squared is 16. 3 squared is 9. You add those up. Does that equal 5 squared, which is 25? And yes, it does. That's the idea of a Pythagorean triple. Now, there's an infinite number of Pythagorean triples, but they're all based off of a couple main ones. Okay, all the other ones in these columns, you can see, you just multiply those numbers by a common scale factor, and you get more triples. Okay, so there's an infinite number of these things, but there's some basic ones. Okay, it's not anything you really have to memorize. It's just these are some numbers that work with this pattern. Okay, so that's the idea of a Pythagorean triple. Now, some examples. Says, find the unknown side length, simplify answers that are radicals, tell whether the side lengths form a Pythagorean triple. All right, hit pause. I want you to try these on your own. Okay, hopefully you got some answers. So for this first one, question number 8, Pythagorean theorem is always leg squared plus leg squared. So x squared plus the other leg squared should equal the hypotenuse squared. All right, when you are doing Pythagorean triple, you have to follow order of operations, which means before you can add or subtract anything, you've got to take care of some exponents. There's nothing to do with x squared plus 12 squared is 144 equals 13 squared, which is 169. Now to solve for x, get that x squared term by itself. So we're going to subtract the 144 from both sides. 169 minus 144 is 25. Now you take the square root of both sides. When you take the square root of both sides, you do get positive and negative answers. So technically, positive and negative 5 is a possible answer. But x represents a side length, so it can only be a positive number. All right, in number 11, same idea. Leg squared plus the other leg squared equals the hypotenuse squared. Now this one looks much more complicated, but it's not so bad. You got x squared plus x squared. Those are like terms. You add them up, you have 2 x squareds. All right, when you square a number like 8 square root 2, okay, there's a couple ways you can look at this. Basically, when you square something, it means multiply it by itself. All right, so I'm going to go with the like numbers. 8 times 8 is 64. Square root 2 times square root 2 is square root of 4, which is 2. So 64 times 2, 128. Okay, that's one way to look at it. Another way to look at this is 8 square root 2. When you square this, you square the 8 and you square the square root 2, which still gives you 64 times 2, so 128. All right, so to solve for x, got to get the x squared by itself. So we divide by 2. Now there's only the one term of x, so we don't have to set it equal to 0. We just got to get that x squared term by itself. So divide by 2. Those cancel out. X squared equals 128 divided by 2 is 64. Take the square root of both sides. Positive or negative 8, but x is a side length, so we're only going with the positive answer. Okay, those are those examples. Number 7 here, again, hit pause. Please try this on your own. All right, to solve this one, basically the same idea. Leg squared plus leg squared equals hypotenuse squared. So, square root of 7, oops, it's not supposed to be an equal sign yet. Remember to take care of the exponents before you do any adding or subtracting. Square root of 7, when you square that, it's just 7. Square root of 19, when you square that, it's 19. Get the x squared term by itself, so we're subtracting 7 from both sides. Take the square root of both sides. Now, when you read the directions, simplify answers that are radicals. All right? I don't really want, oops, wrong direction. I really don't want the square root of 12 as a decimal. All right? It's going to be 3 point something or other. I don't want that. We're moving to a higher level of mathematics. You should be simplifying this, not putting it as a decimal from your calculator. So what you're looking for are factors of 12 that are perfect squares, or at least one factor that is a perfect square. So 12 is 4 times 3. That's, because it's multiplication, we can separate these into individual square roots with still being a multiplication in between them. Square root of 4 is 2. 3 is a prime number. It's not a perfect square, so we leave it inside that square root. This should be your answer. Okay? Number 12, I'll leave up there just for you to try if you want some extra practice with that. Okay. The given lengths are 2 sides of a right triangle. All 3 side lengths of the triangle are integers and together form a Pythagorean triple. Find the length of the third side and tell whether the leg or the hypotenuse. So like I said a minute or two ago, the hypotenuse will always be the longest side. So what we have is a third side. Okay? Don't know if it's a hypotenuse or not. So what we got to do to try this problem or to do this problem is just try Pythagorean theorem. Let's start with the first case. All right, we're going to say our third side is the hypotenuse. That means 12 and 35 are the legs, and so that will equal the hypotenuse squared. Now, how are we going to know if this works? We're forming Pythagorean triple. So when we solve for x, if it works, it's got to be an integer, no decimals. All right, so got the calculator, clear. 12 squared plus 35 squared. Get that answer. Take the square root of it to solve for x. So what we're looking at is 1369 equals x squared. Now we're taking the square root. So secondary square root, secondary answer. So I'm taking the square root of 1369. And it is 37. That is an integer. That means that's going to be our third side for the Pythagorean triple. Now, 37 is the longest of these 3 sides, so it's got to be the hypotenuse. All right, that's the idea of these problems. So I put another example up here, 56 and 65. Do the same thought process. In this first example that we did with the 12 and 35, if we did not get an integer for 37, for that third side, then that third unknown side would not be the hypotenuse, which means 35 would have to be the hypotenuse. So we would set it up as, again, this is just, if we didn't get the right answer, we would do 12 squared plus x squared to equal the longest side squared, and then that would give us our third side because these problems say these are Pythagorean triples. All right, so like I said, the 56 and 65, that's just an extra example if you want to try that. And I'll just do one of these. It says find the area of these shapes, round to the nearest tenth. So, comma, round to the nearest tenth. All right, so we've got a couple of things going on here. We're going to have to assume that this inner shape is a rectangle. So that means this is 26. What we have are some triangles, and if this is a rectangle, these 2 sides are going to be congruent to each other, which means this right triangle and this right triangle are congruent to each other by side angle side. Now, what I'm going to do is break this up into different shapes. There is a theorem that we really haven't talked about yet, but what we're looking at is a trapezoid. Trapezoids have a certain formula for defining the area. We haven't talked about that yet, so let's just break this down into different parts. So the total area equals the area of the two triangles plus the area of the rectangle. All right, so there's two of these triangles. They are the same, so we're going to go 1/2 base times height. Now we don't know either of those numbers for the base and height of those triangles. And the area of the rectangle, well, the base of it's going to be 26 times, let's call this the height. Okay, we don't know the height yet either. So we got to do some math. In this shape, we got this 62 all the way across. Now it's made up of 3 parts. We'll call these the bases here of those right triangles. There's 2 of those plus that 26. Those come together to form the 62. So we got 2b plus 26. When we add all that up, that's our 62. So 62 minus 26 is 42, 36, divided by 2. Each of these are 18. Those are the bases. All right, so that gives us something. 2 times 1/2. Our base of those triangles is 18. We're still missing the height. Now, if you look at this right triangle here on the right side, we're looking for the height. We square that because it's a leg, plus the other leg of 18 squared. That will equal the hypotenuse of 30 squared. So, bring the calculator back up. We got 30 squared. When we solve, we're going to subtract that 18 squared. So minus 18 squared. Hit enter. That's going to be our h squared. Take the square root of that answer, 24. There's our height. So now we're plugging that in. Plus 26 times 24. And now we've got the area of our triangle. What's kind of nice here is the 2 times 1/2, those cancel each other out. And we just got 18 times 24 plus 26 times 24. And whatever the answer to that is, there's our total area. Okay, you can figure that out with a calculator. So, number 32, just an extra example. I'll leave that up there for your pleasure. That's it for this section, 7.1. Hope you enjoyed it. Have a good night.